Dear all, welcome back to our course on ceramics processing. Today, to justify our course's title, we are going to take a deeper look at the processing itself. This is a general flowchart of the processing steps in a typical path for fabrication of a ceramic part. As we have seen before, the main keywords, powder, shape, and heat, can be located respectively at the top, middle, and bottom of this representation. Thus, powder processing or beneficiation includes dosing, milling, which can be either dry at the left-hand side or wet at the right-hand side, besides classification and pre-shaping steps such as granulation, also known as humidification, spray drying, and filter pressing. In this first part of the process, the raw materials, the additives, and eventually some kind of recycled matter are added to form a powder mix or a slurry or slip, depending on the amount of liquid used, which is generally water. The shaping or forming step deserves a deeper look and might be divided into pressing, plastic forming, or casting. After that, thermal and surface treatments follow. Drying is usually held right after shaping. A surface finishing, such as glazing, which is a coating with a glassy slurry, might be included. Last but not least, a final heat treatment comprising sintering or firing is mandatory. Eventually, a final surface finishing, as polishing, might be necessary. Let's now click on pressing. Pressing is perhaps the most simple and common way to give a shape to a dry powder or granule. We might have what is called uniaxial pressing, meaning that the force is applied along a single vertical axis. Alternatively, when the pressure is distributed homogeneously around the piece or powder to be shaped, we have the so-called isostatic pressing. The latter might be either cold isostatic pressing, also known as SIP, or hot isostatic pressing, aka HIP. During SIP, a liquid, water, or most commonly oil, is used as a hydraulic way to transmit pressure around the green body, which is normally protected by an impermeable plastic or rubber-like bag. When HIP is used, we have actually a kind of press inside a kiln operating at high temperatures. In this case, there is normally no mold, so that the piece to be submitted to HIP or HIPed must be preformed by another shaping method. Thus, HIP is actually a thermal treatment rather than a forming technique. Now, we skip to plastic forming, which comprises at least 4 different ways to shape a green body from a paste or plastic body. 2 of them are called jollying and jiggering, and reminds us the movement of a shaping hand used to mold a paste through rotation of a basis. This is pretty much the same that the very first machine used to shape clay-based ceramics, the so-called potter's wheel. Alternatively, we have either extrusion or injection molding. These are multi-material shaping processes, which might be familiar to you from polymers processing. In the case of extrusion, we have as a final product a piece with a fixed cross-section, such as a rectangular brick or a circular tube, for instance. This process is regarded as continuous in the sense that as far as you have raw material entering the equipment, you have an endless line of material being processed. Naturally, from time to time, this material is cut into smaller pieces. In the case of injection molding, the feedstock is a mix of powder and additives, mainly binders and plasticizers, which are fed as granules. Differently from other ceramic shaping processes, injection molding is generally not carried out at room temperature. The system must be heated up to permit that a paste is formed and fills the gap, usually of a complex shape and small piece, which is produced at high speed and efficiency. Finally, our third group of shaping is generally known as casting, such as slip or tape casting. To cast means let a liquid or slurry flow either into a porous mold to render complex shaped pieces or onto a moving plastic band through a so-called doctor blade, which levels up the height of a moving suspension. By slip casting, houseware ceramics such as kitchen utensils or sanitary pieces can be shaped. Tape casting is, on the other hand, the state-of-the-art technique to fabricate thin, flat ceramics, particularly for the electronic industry. Another way to represent the sequence of a typical ceramic manufacturing plant is shown here. This first part comprises powder preparation and forming. Milling and/or mixing is usually performed with a ball mill. When this operation is done with a liquid, the slurry formed might be pumped and dried in a so-called spray dryer, normally with a counterflow of hot air. The so obtained granules might be then dry pressed, isostatic pressed, or injection molded, depending on the shape that we wish to manufacture. In the sequence, we might have some kind of surface machining, which is called green or soft when held before firing. Firing or sintering occurs at furnaces or kilns, which might be of various types and sizes, such as batch or tunnel. Sintering can also take place simultaneously with a press, either axially or isostatically, as we have seen before. Finally, the end shape might be given by surface grinding and lapping using hard tools, generally made of diamond, since here we deal with very hard sintered ceramics. Eventually, the ceramic part must be assembled or combined with different materials, mainly polymers or metals, to give it a final functionality. So, various ceramic shapes and sizes might be manufactured, including, just as we see in this picture, tubes, rings, substrates for countless applications. In order to differentiate some technological roots in ceramics processing, for instance, for traditional tiles, we can explore again this generical flowchart. The first option comprises a so-called wet route, starting with the raw materials being milled or mixed in a ball mill with the help of some liquid, normally water. The produced slurry is spray dried into granules, which are in turn pressed, dried, and may have a surface finishing before being heated and surface treated. Another route, which is called wet route, starts also with wet milling or mixing, but goes this time through press filtration and de-airing to be plastic formed, commonly by extrusion, so that flat tiles can be formed. Those green dry tiles are then submitted to sintering and eventually surface finished either before and or after thermal treatment. Finally, we have the dry route, perhaps not so usual as the former wet routes. Nevertheless, using less or no water at all surely presents some environmental advantages. A powder, in this case, is milled in a dry or low moisture state. To enhance forming by pressing, the powder is commonly subjected to granulation, in which it is transformed into granules with a moisture content of around 5 to 7% water. Granules are easier to flow into the press mode so that a more homogeneous green body is formed. Drying, surface finishing, and heat treatment follow and close the fabrication sequence. A more pictographic representation of concurrent ways to fabricate ceramic tiles is shown here. In this case, a so-called triaxial ceramics that is made of clay, feldspar, and quartz is first wet ball milled and then must follow one of two alternate ways. First, the powder slowly goes through a press filter presenting 20 to 25% water. The paste is conducted through an extruder to give it a shape. In the sequence, this green body is dried, eventually glazed, and set into a tunnel kiln. Traditional kilns such as this one used to take 2 to 3 days at 13,000 degrees C to complete a firing session. Alternatively, a slurry can pass through a spray dryer and render granules with 5 to 6%, which are pressed into tiles. It follows a glazing and sintering step. The latter is held in modern days in the so-called roller kilns in much shorter times in a continuous fashion. In this case, the fire schedule takes 60 to 150 minutes to complete. Nowadays, sintering times of less than 30 minutes are normally used for ceramic tiles in modern plants. To finish, in any case, surface treatments, quality control operations, and packing expedition are normally held in a ceramic manufacturing plant. Let's stop now for some exercises. Please try to answer the next questions eventually with the help of a textbook or just Google it to justify your arguments. Do not copy and paste. Try hard to explain it in simple words using your own ideas. Questions. How can we differentiate ceramic materials by their order of processing? Please use the words powder, heat, and shape. Which are the pros and cons of dry and wet milling or mixing? What are some environmental concerns regarding ceramics processing? Which materials can be recycled into the ceramics processing plant coming from inside or outside? Why granulation should be preferably referred to as humidification? Why the shaping processes are ordered in the flow chart from left to right as pressing, plastic forming, and casting? Where drying is located along the flow chart, please cite 3 different options. Is it preferable to apply glazing before or after firing? Please justify it. Cite 2 different ways to produce ceramic tubes. Are there forming steps which are normally held only for traditional or advanced ceramics? Please present one example of each kind. That's all for now. Thanks for watching. and see you next time.